Howdy, Joel here with Vertical Envelope. I'm here to do an intro demo for OpenRocket. The purpose is really to take you through general operations and how to build a rocket and fire it within the simulator. Alright, so as with most, you can go here to File, and you'll see we've got new open recent examples. And then we've got our save controls. That's typical under the file. Under edit, you've got undo. And under tools, we've got component analysis, rocket optimization, custom expressions, and photo studio. Those are beyond what we'll be looking at today. We'll look at those within another video. But basically, our building, what's required in a rocket? A nose cone, a body tube, a motor tube, fins. That's basically going to get us started. So I'm just going to show you the basics of building this, building it, sizing it, generally setting your sizes. So we're going to start with a nose cone right here. This is the default in here is fairly large. So we're going to build a 28. The nose length is fine. But we need a base diameter of 28 millimeters. So we're going to go in and set that down to 28 millimeters. So you'll notice we have shoulder, override, appearance, and comments here. So as we go through and build this, we can actually take notes and do a number of different pieces. I'm not going to get into the full depth within the build. We'll do that in the next video series, where we go into depth building it. But basically here you can see we've got component material. We'll just go down. Typically we're looking at polystyrene anyway. We'll just leave everything essentially default. So then we close that. So then we move to the body tube. Actually we did accidentally added two there, but what we can do, we can close one off, delete it, then we click on it. If you double click, it'll open that back up. So now if you notice, by default it gives us our same outer diameter here, and wall thickness of 2 millimeters. That's going to be a bit thick for what we're looking at, so we'll drop that down. So we'll drop that down to 0.5 millimeters there. This isn't going to be a motor tube, but we'll make it a little bit longer too, so this will balance right for us. So 200, let's go for 500 millimeters on that. If we want to, we could actually go in and change these, change our sizes here. So from millimeter, centimeter, meter, inches, and it will convert automatically. So setting our units is quite nice. We'll keep it as cardboard, and we'll hit close and see that extends this. That gives our extension right there. So next part we're going to move to, because we're on the body tube, and you'll notice when I wasn't highlighted on the body tube, when you're not highlighted on the body tube, it only gives you the ability to go in here, create a nose cone, a body tube, or a transition. We're not going to deal with transitions today. We're just going to build a super simple rocket, but we could add another body tube, but that's all it's going to let us do there. But then you see the inner components. To add inner components, we actually have to go down here to the body tube and then go here. Then we'll click on the inner tube right here, and basically this is giving us an inner diameter for an 18 millimeter motor, which that's just right, outer diameter. Okay, I'm okay with the 19 on that, so 0.5 on the wall thickness. So see, it's dropping it right here under the body tube. So that's pretty much good to go. Cardboard, we're fine with that, but what we want to do is we want to click on this motor where it says motor right here, and note that this is a motor mount. And automatic launch or ejection charge, all of this is fine. We'll deal with some more of that a little bit later in our other videos as we get more precise in our builds and actually following building a model. So we'll close that off. Anytime you have a body tube, that's going to need to be attached with centering rings. So we'll do our first centering ring here. So our outer diameter was 19, and our outer diameter is going to be, so we did 24, so we're going to be 23.5 on our outer diameter. This is the ring that's on the inside, and then the inner diameter is going to be 19. That's what we had set up on our 19, and our thickness we can go up to probably about 3 millimeters, and let's say a lot of time, well, cardboard's going to be fine. So, and let's see, our outer diameter. All right, and then you'll notice this slider right here. Watch what we can do. We can actually slide that up. So we'll actually make 2 of these guys, and that outer diameter we can go up on this 24 millimeter. Actually, I think I did 28, so it would be 27.5. Yes, there we go. So that one sets up right there, and we've got our first one mounted. And then we can go in and go back to our inner tube and create our next one. And we'll set it at 27.5 and 19. Our thicknesses are good and close, and we're right there toward the back. You can actually see we upgraded this one to 3 millimeters. That's 2 millimeters, and if we so desire, we can move that forward just a little bit. So that's going to set and move. Oh, that moved back for us. Or you can actually go in and type in the numbers as well, to be, if you're looking for a little more precision in doing that. So now we need to add our fins. So we're going to go back to body tube and then click, we'll do trapezoidals, and we'll do number of 3 fins. So notice there's our default right there. And then as we put the fins on, we start to see some interesting things take shape. You'll see kind of this blocked out X circle. This represents center of gravity right here. If you see where the mouse is, then over here to the right, you'll see the red dot. This represents center of pressure. Now, for safety reasons, and anytime you're flying rockets, you always want your center of gravity to be ahead of your center of pressure by at least a diameter of the rocket, preferably more. We haven't loaded our motor in yet. When we load the motor, we're going to see this shift back. So we're just going on length and fin size, and the system, OpenRocket, calculates a center of pressure based on the fin size and what we design on our fin size. Like if we go in here, we can change our root cord and extend that up. And notice as we move that forward as opposed to sweeping back, you can look and see what's happening with that center of pressure. Notice that the center of gravity stays the same, but what shifts and moves around is the center of pressure, that red dot right there. And that's an important key anytime you're designing your rockets. And if you're building something, you're not building from a kit, and you want to try something out, you can simulate it, and this will give you a really good indicator of where your center of pressure is going to be. I found this to work really well. So we're good default right there. So we're going to go on and move on. This is our general rocket. We'll look at parachutes. We'll look at doing mass changes and such like that further on. This video is just to give you general operation of this. So then we'll go to motor configurations. We'll select our inner tube right there. We'll create a new configuration so it's got no motors, and go to our default inner tube, and then we'll select a motor. So this is 18 millimeter. So what we'll do is we'll go right here and we'll move this slider to 18 millimeter and this slider down, and what it's going to do, it's going to give us only our 18 millimeters. It tells us who makes them. It tells us the length of them, all of our general information, and who the names are. So you see the normal Estes, Quest, if you can still find some of those. You see we have Aerotech. Aerotech, if you go out to some of the larger launch sites, you may be able to find some of the Aerotechs. And with our club, we actually have some of the 18 millimeter reloadables. So these are actually motors that you're able to get the accelerant or the ammonium perchlorate that you actually load in yourself. But for the most part, we're going with Estes. So let's choose. So for safety, because typically you want to go with your lowest powered motor to test and see that it's going to fly for you. Actually, looking at the size of this, we're going to need a little bit more performance. So I think we should be fine. We should be fine going with let's use a B6 because we're at a 28 millimeter. We're at a 28 millimeter diameter rocket body, so it'll need a little bit more power in that. So we'll start with that and we'll click OK. So notice it shows our configuration. That's our B64, and then our inner tube is the B64. Then you look down here, that's you see the motor set in here. And if we look for a good check, we'll notice our center of gravity. Okay, that's well beyond what the diameter difference is back to the center of pressure. Now, what's really cool before we move to the flight simulation portion, if you look down here in the lower left-hand corner, it gives us apogee. Okay, this is going to fly to. It's telling us this is going to go to about 122 meters, or almost 400 feet. We can expect up to 400 feet. The maximum velocity is 58.5 meters per second, or 0.17 Mach. And guess what? You can actually, the motors that we have in here and designs, you can actually design and simulate rockets to go over about Mach 3. But you have to really get your designs down, and I encourage you to have some fun after taking this little tutorial here. Start just putting pieces together and see what you can make happen. And then maximum acceleration is 185 meters per second. So that gives us an idea of what's going on here. We're not going to look at recovery or stages. That's more advanced. Like for our TARC teams, we're going to be doing some TARC videos as well. We're going to get into recovery and stages and talk about how those work in some upcoming videos. So like and subscribe, and those will come up for you. All right, now flight simulator. So we've got the simulation set over here. And notice we could actually, it allows us to go in and start the simulation. So we will go over here on the, and within simulation, we can go in and change multiple ones. So where I created a new simulation, then we can actually take this back. This follows back over. This is where you can go in and test different variations. So from our initial simulator, we select it and then we run simulation. And so what that comes back with, if you notice down here at the bottom, this is what it's expecting to do off the motor and running the simulation. It's going to be 121 meters, 4 seconds, 4-second delay. So we picked a B64. So actually that's just the right delay. This is more interesting in the motors, the reloadable motors. You're actually able to go in and change your timing on your delay. This can be fairly important. This is actually really important and where your apogees are and the chutes, when you need to release the chute and such like that. So that's important there for you. So that gives us those times there. And that's basically set up with a simulator. We could go in here in the second simulation, and we can go in and change portions of that. See, I kind of opened that up a little bit earlier, but as you notice, we can set a rod length, we can set where we are on the earth, we can set the type wind conditions, everything going on. We're actually able to go in and set, we're able to set the altitude that we're flying from. So we're not going to fully jump into that within the context of this one. This is basically to give you a great idea of how this operates, so you can get to building your rockets. All right. Thank you.